So this week, we're going to start hyperbolas. We've got, we'll do it's the last of the conic sections. Okay? So it'll be the last section of your supplemental note sheet that you need to fill in. So you might want to have that out too. It's the biggest section of your supplemental note sheet to fill in. So there's that. Okay. We are going to be graphing one, maybe two today. So if you think that you need a fresh sheet of graph paper, there's some right there if you want to grab some for your notes. What else can I say about hyperbolas? This week, Friday, is a summative quiz again. Okay? So we're on the summative week. Last week was a formative week, so this is a summative week. We're alternating. We don't have to worry about pre-ACT tomorrow because class doesn't meet. I'm trying to think what else. I think that's it for announcements for today. Okay. So a hyperbola is a conic section. You don't have to write this down, but it's a conic section where the difference of this purple line and this orange line is the same. So in an ellipse last week, it was the sum of the distances to the two foci was the same. Here now, it's the difference of the distance to the two foci is the same. Okay? So the distance to any point on this hyperbola has the difference between the distances to the two foci is the same. That's the technical one. Okay? I am not going to lie to you. Foci is the most involved of the four conic sections. Okay? There's the most stuff for it. There's the most things to figure out for it. So that's why we saved the biggest spot on your supplemental sheet for it. So on your supplemental sheet, I would start by giving the two equations. There are two different equations for hyperbola. Because now we have a subtraction sign in between the two squared terms. So if it's x squared minus y squared, then it is a left and right opening hyperbola. If it is y squared minus x squared, then it's up and down. So definitely want to write down both of those equations on your supplemental notes. Now, a lot of the concepts that you've learned over the course of the last 3 weeks will still come into play for hyperbolas, but we get added some more here, some more steps added. Okay? So like I said, the differences in those distances is a constant for any point that's on the hyperbola. That is, once again, the mathematical definition of it. Okay? Where you can see some hyperbolas in real life, this is my favorite one. If you get a good lampshade that's got a nice big top at the bottom, it can't be one of those like straight ones. The new lampshades are all at straight sides. It's got to be a flared out side type one. If you see that and you're in a dark room and it's right at the right distance from the wall, you'll see the upper hyperbola and you'll see the lower hyperbola from the shadow on the wall. Sonic booms from jets are in the shape of a hyperbola. An hourglass is in the shape of a hyperbola. It's this part right here. Here's the hyperbola. Radio location, radio signals, and triangulating. This planetarium in St. Louis is in the shape of a hyperbola. It's kind of cool. Okay. Again, you get a hyperbola by taking the double cone that we talked about 3 weeks ago. You take the double cone and you slice it vertically. That's how you get the hyperbola. Yeah? All right. So let's dive into one. This is going to be the example that we graphed. Okay? So if you wanted to do this on your graph paper, that's fine. But then we'll fill in the supplemental sheet as we go along. So this is the one that we are going to graph. Okay? So I'm teaching right now stuff that you need. So go back and sit down. I know, but you're in class right now. I know, I'm the meanest. Okay? Alright? First thing, what's the first thing you think we gotta find in a hyperbola? Center. Yep, where's the center gonna be? Not just in this one, in general. Where's the center gonna be? I know, but where? Like what, I'm sorry, what are the coordinates going to be in the general case? H comma K? H comma K, just like it has been. Just like the vertex was for us in parabolas, just like the center was for us in circles, just like the center was in ellipses. The very first thing that we are going to do is actually, I should say, first we identify the direction of opening. Okay? Right? So that's that x squared minus y squared, or y squared minus x squared. Okay? This is an x squared first, so it's a left and a right opening for a hyperbola. Two parabolas. Okay? So then the center, just like before, is going to be at the point H comma K. So where would the center of this particular hyperbola be? At 3 comma negative 2, correct. Whoa. So we are going to mark that on your graph with a C. We're not going to put it in a dot because it's technically not on the hyperbola, but the center is a very extreme part, the first thing that we have to do to find it. Okay? So we would go to the point, we go 3 right and 2 down, and we put a little C on our graph. I don't think I have that until over here. So we would go 3 to the right and 2 down, and we would put a C, just like that. Okay. Step number 3. Now, we're going to build a box around the center. Okay? And so the box is going to be built very similarly to how we built our ellipses last week. Okay? So we're going to look underneath the x squared term. In this case, that is 9. We're going to take the square root of it because that's technically a squared. Okay? So a then would be 3. So I'm going to go 3 to the right, and I'm going to put a dash. And I'm going to go 3 to the left, and I'm going to put a dash. Okay? Those are going to be the left and the right sides of my box, which is why I only put a dash that far out. I don't know how far up or down I'm going yet until I get to step number 4, but so I'm right there right now. Okay? Now I gotta think if I gotta bring this graph with me or not. I do have to bring the graph with me. So that would be a better job for the mouse, I feel. Copy, go over, and paste. Okay. Oh, wait. Tap the brakes. Must be at the bottom yet, because we got to build the top part of the box. Oh, yep, I didn't go. I kept it. I'm trying to remember how I changed it up this year. Last year I made it be like 17 with like 9 steps. I think I shortened it up a little bit. Okay. So then we're going to look underneath the y squared term. And that's going to be how far up and down we go. So the y squared term is 16, which means the square root is 4. So therefore, we are going to go up and down 4 from the center. Again, putting dashes. And now we're going to lightly draw. I would even say, if you, just so that you're okay with it, I would go with a dashed lines for the box here. And I wish the third floor would figure out where they wanted to put their desks so they didn't have to keep adjusting them all day, every day. Okay. So you've got a box now on your graph. Everybody with me so far? Okay. Okay. Now, the next part, step number 4, is actually really important to that one. We're going to draw in, so now this would be, again, preferable with something straight, a straight edge of some kind, either on side of another piece of paper or a ruler or something along that line or an ID. We're going to draw in the diagonals of this box now. Too far. Double click. Okay. So I'm going to grab a straight edge and I'm going to draw in the diagonals of this box. And I'm going to extend those diagonals a fair amount past the edge of the, come on, work for me now. I know. For some reason, on these BenQ boards, it doesn't let me extend, there it goes. It doesn't let me extend a lot. Right. We're going to extend off a fairly good ways off of our graph. And not just through, and those are going to be dashed because those are going to be asymptotes. Okay? That's going to confine our hyperbola. If it's a left-right hyperbola like we have, it's going to be in these two left and right sections. If it's an up-down hyperbola, it's going to be confined inside this upper and lower section. Okay? Now, we've got to find the equations of those two hyperbola. Okay? So, let me go in here and look for 8.4. For sure, they go through the center. Okay? Both of your diagonals are going to be going through the center. And both of your diagonals are going to have slopes. Now, the slope of the diagonals is going to be, one's going to be positive, one's going to be negative, and it will always be your B value divided by your A value. Okay? So the slope is always going to be plus or minus B divided by A. So in this particular case, then, that would be plus and minus. My B value was 4. My A value was 3. So the slope of the positive, the one going up and to the right, is 4/3. The one going down and to the right is negative 4/3. We want them to both be in y equals mx plus b form. Always goes through the center. So my center is going to have the, whoa, why is it, ay, caramba. Oops, that breaks. Okay, y now. Here we go. So the center has a y value of -2. It has one of them's got a positive slope of 4/3. It's got an x value of +3. And I need to find the b value for that. At the same time, I'm going to set up my other one. The only thing that changes is now, instead of positive 4/3, it is negative 4/3. 4/3 times 3, anyone? Four-thirds times 3 is 4. So this is going to be -2 equals 4 plus b. Subtract 4 from both sides, and I get -6 is equal to b. Over here, we get -2 equals -4/3 times 3 is -4 plus b. Add 4 gives me 2 is equal to b. So the equation of this asymptote is y equals +4/3 x minus 6. The equation of this asymptote is y equals -4/3 x plus 2. Could have we gotten those right from the graph? We could have gotten those y-intercepts right from the graph, yes. But that's not always going to be the case where your y-intercept with the edge of a box is on the y-axis. Yeah? So, teach you how to do all of that. here. This now. Step 5 now says that we need to identify the two vertices. The two vertices are going to be the midpoints of the sides of the box that we just made on the two sides for the direction of opening. So since this was an x squared minus a y squared, okay, that means that the vertices are going to be at the midpoints of the vertical sides of the box. So my first vertex is going to be at 0, negative 2. My second vertex is going to be at 6, negative 2. If it were an up-down parabola or hyperbola, it would be here and here. The midpoint of those at the top of the box. Everybody with me so far? I feel like I'm not doing a very good job of making too many verbal mistakes. Changed up the way I thought about things. Everybody good though? We'll clean it all up at the end. Now, step 6 says we can draw in our hyperbola. And so we draw it in by just doing this. And it ends along the asymptotes on both. Oops, that was a bad one. Then we got one last thing to find, and that's the two foci. So let me put this in here. Whoa. Last thing we need is the foci. The important equation for the foci is a squared plus b squared equals c squared. Where have you seen that before? Yeah, you should have. It's Pythagorean theorem, right? Okay. So a squared is the number underneath the x term. B squared is the number underneath the y term. And c then is going to be the distance from the center to the focus. Okay. So a squared plus b squared is going to be 9 plus 16. 9 plus 16 is 25. Square root of 25 is 5. Okay. So since this is opening left and right, oops, let me go back up here. Let me put the center on this, on our list of points too, since we have everything else listed. So since the center is at 3, negative 2,
why it is acting so goofy. Okay.
Since the center is at 3, -2, and it's a left and right opening, we're going to add and subtract this 5 to the x part of our center. So the foci are at 3 + 5, which is 8, -2, and 3 - 5. We can put those then on our graph. With an F.
Yeah.
All right. So, put it all back together here now. So on your supplemental note sheet, you should have the 2 different equations for a hyperbola. Yes? Everybody got that on there already? Okay, good. Then you should have the 7 steps to graphing a hyperbola. First off is the directions of the curves. So that's going to be if it's x squared minus y squared, then it's left and right. If it's y squared minus x squared, then it's up and down. Our center is step number 2. That's going to be at the point h, k. We build the box. A is left and right. B is up and down. Both of those are from the center. Then we draw in our diagonals and come up with y equals mx plus b for both of them. Vertices are going to be on the side of the box. The same sides of the box as in number 1, the direction of opening. So if it's left and right, it's left and right sides of the box. If it's up and down, it's upper and lower, up and down sides of the box. Drawing it in is just drawing it in. Foci is Pythagorean theorem. And it's inside the curve. Okay. Which done? Of course it did. Alright, well, hopefully we'll see if it continues to record while I hand out homework. So I'm handing out the homework right now because I want to do number 1 on the homework together. Actually, let's do number 2 together because it's a different style than the one that we already did. Okay. So number 2 is y squared over 36 minus x squared over 64 equals 1. Okay? So first step, which way does it open? Up and down, because y squared comes first, right? Okay? Right? So step number 1 says it opens up and down. Okay? Love it. Step number 2, where is my center point? 0, 0. Everybody agree with this? Center is at the origin. Okay. Now we've got to build the box. What is my A value? 8, because A is underneath the X. So my A value is 8. So that means I'm going left and right 8. 8, I put a dash. 2, 4, 6, 8, I put a dash. What is my B value? 6. So that means I'm going up and down 6. That's only 3. And then I draw in my box. Step number 4 was what? Diagonals. Then I got to come up with the equations of those. What are the slopes of those two lines? Plus and minus 6 over 8, which reduces to 3/4, right? Because it's B over A, so it's 6 over 8, which reduces to plus and minus 3/4. Now this one had a center at the origin, right? So looking at those two lines, what are both of their y-intercepts? 0, because it's where it crosses the y-axis. So both of them are 0. So one of them is going to be y equals 3/4 x. The other one is going to be y equals negative 3/4 x. Step number 5 was vertices. Since this one opened up and down, we're going up to the midpoint of the top of the box, and we're going down to the midpoint of the bottom of the box. So this would be 0, 6 and 0, -6. Then we can draw it in. And lastly, we need to find the foci. The formula for the foci was a squared plus b squared is equal to c squared. So that's going to be 64 plus 36. 64 plus 36 is 100. What is the square root of 100? 10. Okay. So my foci are going to be up and down 10 or left and right 10. Up and down. They got to be inside the curve, right? So I think I gave you tens and a line of tens. Oops, I put 10, 0. And that should answer all of the questions. We've got the graph, we've got the center, we've got the direction of opening, we've got the 2 asymptotes, we've got 2 vertices, and we have the 2 foci. Okay. We saved this one for last because it's got the most to do with it. Step number 4. Or did you mean like what are they in terms of the graph? Or did you just need equations with filling? Just for filling. That's the diagonal graph. Okay? You can, yet today if you want, I mean it'd be good to do, you can do the other 5 on the front side. I would wait to do the ones on the back side until we get to Wednesday or Thursday. You can for sure at least start the ones on the front side.